Oguz Haliloglu brings over 25 years of experience in the telecommunications industry as an entrepreneur, technologist, and executive to his role as Chief Executive Officer of Defne. He says technical problems, equipment failures, fire or water damage, and similar incidents and natural disasters can have costly consequences for a business and a community. To guarantee the safety of individuals, groups, and infrastructure within an organization, a rapid response to such incidents is essential. Solutions then that notify individuals or entire groups of people in real time when such incidents happen can of course save lives, but they can also increase operational efficiency and reduce costs. Is public cloud database as a service the answer? Well, let's find out. Ladies and gentlemen, please welcome Oguz Haliloglu.
Hello, thank you very much, Adam. Thank you very much for introducing me. I'm glad to be here presenting my keynote presentation on emergency notification. We are a company in the telecommunications domain, but with a special focus on emergency notification for years. As Adam expressed clearly, nowadays emergency notifications became more and more important because we all rely on IT infrastructure and telecommunications to carry out our works, even if there is no danger or hazard around us. And emergency notification systems, they really take a hidden part in our life. I will start with describing what an emergency notification is. We probably all know what that is, but it is a one-way dissemination or broadcast of messages to one or many people, alerting them for a pending or existing emergency situation. It has to be, emergency notification has to be in cases of considerable destructive or catastrophic damage threat, like natural disasters like tornado, storms, etc. In the past, there had been some standards and systems to do that. Most common one, I would say, is the commercial mobile alert system, CMAS, but nowadays that's being replaced by the wireless emergency alert besides others. Why that is important? Of course, this is the question. I mean, we know it is important, but why that is? Because we need an early warning system. With early warning, people can get notified about the actual danger and hence can take preventive measures to avoid human and economic losses. We can direct people to right directions, we can evacuate them, intervene the case, and prepare rescue operations. People can be mobilized to move away from the location of the disaster, and we can send public safety messages to convey recommended actions. Besides that, people can be informed about crisis protocols, what to do when there is a crisis, in order to a crisis or danger, to support decision making and to solve ad hoc real problems, because we actually don't know what's going to follow up. From the experience that we have locally here in Turkey, we know that, for example, quakes are being followed by other emergency cases that we taken into consideration. So ad hoc is also an important part here. There are some key factors about emergency notifications. What these are? The first thing is that our experience shows that emergency cases are local and geographically distributed. So what does this mean? We do not have in an emergency case at this time a widespread to entire country or entire the world, but it's rather local at one town or city. Technically, we call these as zones, circles, or polygons. So we can make predefined zones or circles, or design polygons to include only the regions that are affected and require an emergency notification. And this distribution is uneven. So we cannot say that every place will have an emergency case. And if we take a slice of 24 hours and a scope of globe, we will see that globally they are distributed over 24 hours. So at any time you can have an emergency notification requirement at a point on the globe. Yet another thing is we do not actually need personal information or GDPR sensitive information. That's not really necessary for emergency notification because emergency notification focuses on rather masses. We target to inform more and more people, notify more and more people. Actual personal information is not that important. It's also target area based. So as I said, we need to focus on a target area. And in this case, just informing or notifying residents is unfortunately not enough. Roamers, visitors have to be taken into the consideration, and they have to be informed using, if possible, their native languages. Otherwise, a pretty common and known language. Yeah, so the other thing is that whatever a means you use in emergency case, this could be an intervention system or notification system. You need a high throughput system, and redundancy and resilience is a must. So any system that is not high throughput will probably not be that useful in a case of emergency. Typically, emergency notification process starts with an event. So we get a trigger. This could be started by a person, a contact, a button or something, a call, a web service or a protocol. And the process will immediately the rules. So what to do, who to inform, where to focus, and load the recipients or recipient rules and start the notification. Another aspect on that is that it has to be omni-channel. So if you use only a single channel for notifying people, probably that will get stuck at a certain point because I will describe this later, but single channel might not be the best solution in a case of emergency. People prefer different channels. People get the messages from different channels more frequently and more carefully. And the instances that deliver these messages have to be pretty optimized. An unoptimized solution will not probably work in a case of emergency. And yet there are additional requirements of emergency notification during peak hours because, first of all, we cannot determine the peak hour for emergency. We don't know. I mean, there could be some predictions in certain cases, like I think when a tornado will reach a certain place can be accurately calculated, but we cannot have a prediction about an earthquake, or even for less critical cases, you might not have a prediction where there is a telecommunications outage. So it has to be kept in mind that peak hour for emergency notification cannot be really determined. And one yet other thing is that as we cannot determine the peak hour, the off-the-shelf systems in the telecoms especially are shaped for Erlang traffic, which is distributed over time, reflecting the usage pattern of the individuals. So any system based on or designed based on Erlang traffic That's probably will not be very useful in the peak hour of an emergency case. The other thing is that during this peak hour, any system that is being used for emergency notification has to have a dedicated throughput whenever needed. So if you cannot provide that good throughput, you will not probably be reaching the target audience, the target individuals, and inform them that a danger case is pending. The design must also involve automatic scalability as soon as possible, probably instantly. So it has also be capable of increasing that instant. We know that because we have experienced that in real emergency cases. So we all know the aspects of public cloud, and we know the advantages of public cloud because it is very common, visible or invisible, but we are actively all using that either in telecoms or as OTT services. Public cloud reduces the time required to boot new service and instances, so it helps in the scalability. They have availability zones and regions, so it helps really in reliability and redundancy. They have resilient storage, and the workloads are tuned for capacity. So yeah, public cloud is really has some matching parts with emergency notification. And the ones that I have picked up and we have from our experiences, we know that match the best are high performance and scalability, high availability and durability, the high security public cloud provides, and being fully managed service that really helps in emergency notification cases. So we are going to evaluate one by one these aspects and how do they match with public emergency notification requirements. Now, if we take the reliability, public cloud gives us database as a service. They have availability zones, they have the resilience, they have the automatic recovery, which all are fine and seem to be fulfilled the requirements of emergency notification. Public cloud offer performance, so they have auto scaling, which is really a nice feature. The serverless architecture, which is even better because I will explain that later. And they have continuous scaling, so your requirements may increase, but you know that your public cloud vendor or will be scaling capacity. They have pretty good and decent security services and solutions with encryption, key management, and certificate management. And also they provide geographical distribution. So the processing, we can really bring the processing to the endpoint where the actual requirement is. And with edge computing regions and availability zones, we can achieve the geo distribution and map the actual load to actual locations. Now, what do we utilize from database as a service? Besides the high availability and security and being fully managed, I think the most important aspect of database as a service is that it gives us multiple data model capabilities. In emergency notification, we require graph data, we require key value, we require relational data. I mean, in your design, you can use them or you cannot, but the public cloud gives you all these opportunities. So you have the freedom of using one or more of these technologies. And the other thing is that database as a service really gives a low latency read replicas. This is important because emergent notification basically reads a lot, but does not write that much. Updates and writes are too few. So any solution for emergence notification has to be read optimized, and database as a service really gives us this chance, this opportunity very clearly and very efficiently. The other things, fault tolerance, self-healing, recovery from storage failures, security, and being managed, they also do help. But for me, I will take as a first and most important point the capability of using multiple data models and read optimization. If we take the reliability, also the public cloud gives us regions and availability zones, data processing close to endpoint, near real-time or real-time communications, resilience, minimized downtime, fast recovery. But also, on top of all, it gives us a mass amount of diversity. Diversity is important in emergence notification because basically you should take into consideration almost everything in emergence notification. So you are not bound to only public cloud, but you could have a hybrid cloud, a multi-cloud architecture, or even an inter-cloud architecture to reflect your local requirements, your regulatory requirements, and your application requirements to benefit the cloud architecture in the most efficient way. So at least having these possibilities brings a lot of advantages to the emergence notification system. Yet another thing is performance. As I said earlier, auto-scaling, auto-provisioning and deprovisioning is one major aspect of emergence notification, because emergence notification really needs a lot of performance, incredible performance. So what does public cloud provide us here? Scheduled performance, scheduled scaling. That's we need, because from time to time we need to make tests that our emergence notification system really functions well and really provides the performance that we require. So you can schedule it on your public cloud. It has dynamic scaling. It has predictive scaling, which is also important. The serverless architecture being a trigger or event-based system. This exactly maps how emergence notification works, because in emergence notification, we get a trigger, an event that something is happening somewhere. We pick up the target audience and we start delivering. Without any event, the system sleeps, literally. It doesn't do anything. Once there is a trigger or event, it wakes up and starts pushing the broadcasting notification messages. So that we take it pretty seriously, and we like that feature. Real-time data processing, as I said, emergence notification requires a lot of data processing. So this is important. You should keep this into consideration in your design. Continue scaling your vendor cloud vendor will give you the scaling whenever you want continuously. So you will not need lengthy deployment and configurations. So it will really save operational time and cost to you. And you should also consider inter-cloud architecture to have a better overall quality of service and resilience to cloud service outages, because even though rarely we do face them, and we should and we are taking actions to prevent to that one as well. Security, yeah, I will probably skip security because I don't have much time. We know all the security aspects. I will focus more on geo-distribution, sorry. The edge computing regions and availability zones really enable us bring the processing we require to the point that emergency notification is really needed. But here, we need to take into consideration the diversity options. So there is a massive amount of diversity here, again, with hybrid clouds, multi-clouds, and inter-cloud designs. Hybrid cloud could be especially important if your regulations really make your life a bit tough to keep the data within national borders on within national data centers. But others, multi and inter-cloud is also important for performance and resilience. My final words will be that public cloud offerings really overlap with emergency notification requirements. It provides the safety and the resilience. It provides the scaling and throughput. And probably one of the most important things here is that provisioning and deprovisioning on public cloud will reduce the cost of rarely used emergency notification services. We have to use them rarely to be on a really safe place. And there are massive possibilities of diversity, but you should be designing your solution based on that. You should be engineering that. And you should also be considering multi-cloud, inter-cloud, or any hybrid technology. I strongly recommend that. Thanks a lot, Adam.
Oguz, much appreciated, sir. I mean, you know, I want to sort of put a pin in something in particular, if I may. We're clearly talking about a life-saving technology here. What do you see as the potentially its most significant impact, and where are we on the journey to that point?
Well, I mean, the technology continuously changes, and we are getting new and new stuff. I think we need more to adapt early detection systems and integrate them with emergency notification systems, because the most efficient and life-saving use case of emergency notification systems is in preventive notifications before the emergency case occurs. So there should be some investment and technology advancement in early detection systems coupled with emergency notification. And with 5G being deployed now quite widely, will really help to overcome the bottlenecks we used to have in lower technologies like 3G or 4G, and provide a much more rapid notification, even in the emergency case has occurred. So different frequencies, different technologies, or different notification methods will help us inform more people in a more rapid way and save more lives.
And in the sort of, you know, trials and tests and you know, rollouts, et cetera, you've done, What have been the kind of standout lessons? Is this, I mean, it sounds incredibly obvious. Is this easy to implement? Is this a complicated thing to implement? Does it require an awful lot of technological skills? What are the sort of customers saying to you?
Adam, it is anticipated easy, but in fact, you need to take a lot of things into consideration. Because as I said, one can think of an emergency notification system is not much different from a legacy notification system. Like you can send messages with SMS, for example. It's very trivial, basic. But if you try to send hundreds of thousands of SMS messages to a region, to a specific region at a very short time, then you see that it's almost impossible. So you need to re-engineer everything to reflect the requirements of emergency notification. Your legacy solution probably will not work there. So for us, it's easy, yes, because we have been working on this topic for quite a long time. But also, other companies can get into that, and we can share our expertise with them. But there are a number of things that they have to take into consideration. And the most important thing I would say is their local conditions. I mean, emergency notification also relies on local use cases. So if like you are in a place and people are not really looking at their text messages, so in case of emergency, there is no meaning for you to send a text message to them because, let's say, people are more voice oriented. So you could broadcast a voice message probably, or OTT message, or continuously make some other notifications. I don't know. You should take into consideration your local dynamics, your local culture, and your local infrastructure as well. So what is the infrastructure you have? The system you are putting there and the technology you are utilizing have to be in line with the technology or infrastructure you are having locally. On the global scale, that has to be omni-channel. You should be using almost all channel that you have because your audience or your target is the entire world and the entire spectrum.
Yeah, of course. And I was going to ask you where we go next, but let's kind of crack on. How reliable is public cloud database as a service for emergency notification at present? What are the immediate challenges? So is there stuff that needs to be made more resilient?
They are quite reliable, but to increase the amount of reliability, one should consider inter-cloud or multi-cloud architectures because it's still a shared environment. So not all cloud vendors have database as a service available, and I mean it is available, but it might not be locally available at all regions and availability zones. So you might not be compliant with local regulations. So technically, it is very. Technically, I don't see any challenges. But in case of emergency, just for the sake of resilience, I would consider a multi-cloud architecture to use different technologies, different public cloud vendors to store the data to be really on the safe side.
And I know obviously you're aware of time, and you kind of not skipped through, but sort of maybe motored through the security slide a little bit quicker than perhaps you would have liked to have taken time to do. But I am curious. I mean, security and safety is all about rapid response. How do you balance that need to be very secure with the need to be very, very quick?
Well, that's another thing. As I said, emergency notification does not really require personal information. Personal information is important, but probably the most important thing is that without knowing the identity of the individual. Just we need to know the language, his native language or her native language, or any language that is accessible to that individual. So whatever security actions and measures you do, whatever encryption you do, you have to do that prior that emergency case occurs. So if you like encrypting like telephone numbers, let's say, you should have encrypted that in a way that once you are in an emergency case, you will decrypt it, or the endpoint will decrypt it very, very easily, and yet provide you with sufficient amount of security. In this case, yes, there is a challenge, but at least what we see is that regulatory bodies and authorities tend to push vendors to keep this data locally at local points, like data centers of telecom operators or local data centers. In this case, we can utilize some features of databases for data governance, and we can place the sensitive data in hybrid clouds to the on-premise servers, and non-sensitive data on the public cloud, and achieve a high performance.
Of course. Oguz, thank you very much indeed, sir. An absolute pleasure to talk with you, and the very best of luck with it all. Clearly an incredibly noble thing to be doing. Thank you very much indeed. Take care, Oguz.
Thank you very much, Adam. It was a pleasure for me. Thanks a lot.
Bye-bye.